Welcome to another thermal system design tutorial. So in this tutorial, we're gonna start looking at the solutions for the problem 3. We're gonna see the contours for the velocity, temperature, and the plots for the velocity, temperature, and pressure at different distances of the down the stream. We're gonna solve for the surface heat transfer coefficient and the total heat transfer rate, the velocity, and the thermal boundary layers. So the first thing that we do is that we go to graphics. We go to graphics and we click on contours, double click on it. We will select velocity. We save in this plate. I'm gonna open our color map. Let's put our color map at the bottom. Apply it. So we can see here our velocity. You can see how at the beginning how it is and how it's developing around down the stream. It's gonna be a little bit more clear to see it, the development at the in the plots. So we have our velocity right here. If you want to see now our temperature, we're gonna close this. We'll click on temperature, save in display. Just from looking at it at this distance, we can see that the temperature from the beginning up to the end, we can see how it's developing here at the layer of the walls of the pipe. We can see that the more we move downstream, the thicker the lines are, meaning that our temperature is developing more and more down the stream. So also something very interesting to see in the plots. Sometimes just from the contours, we're not going to be able to take any conclusions, or it's not going to give us a very accurate representation of what our solutions are. So we're going to close this and we're going to go to plots. We're going to click on XY plot. If we set up, we're going to create new surfaces. Notice that now it's in meters. I'm going to change this to, I'm going to change the units to our inches. We have length, change it to inches. Close, create a new line. So now remember that when we created our geometry, we created it from the origin to the top and then down. So what we're gonna do, if we want different lines, we're gonna create 5 lines every inch. For our velocity profile, we're gonna see that on our velocity it's gonna be very developed at the very beginning, so we don't have to make them apart that much. But on the temperature, we will have to need more lines. So if we go to our y0, let's move x to 1 inch and 1 inch, and it's from 0 to 1. That's how we can create our first. Let's call this line 1. Create. And let's create line 2. Now 2 inches apart. Create line 3, 3 inches apart. Create line 4, 4 inches apart. Create line 5. Now I'm going to create the ones for later for the temperature, every 10 inches. Create line 7, 15. Line 8, 20. Let's create the last one, 25. If you wanna take a look into the different layers, you can go to meshing, to our display meshing. You can see our outline, and you can see the different lines. I'm not gonna do it right now. We'll see them on the different plots. So first of all, we change our plot direction. We're gonna change it to Y. We're gonna want to see the velocity first, velocity magnitude, and let's plot line 1. So we can see our line 1. It's more typical to see our velocity profile being developed on the more horizontal, on a more vertical direction. So we're gonna change the position of the x-axis to a y-axis. This is the, change this to velocity on our x. So when we plot it, we can see now this is more likely of more similar to any velocity development that we can look at. So if we go to velocity profile, maybe this is more likely of what we will see on any given problem, as we can see our velocity being developed, how it looks. So we close this. So let's say that we want to look at it on our line 2. We can see now that the curve is changing the more we move down the stream. So this is our velocity plot. We can see that at the very end, almost on line 5, if we plot it like that, it's more similar to what we would expect on our velocity development. That's how it would look. We also want our temperature. So let's change this to temperature. Let's have all these new created lines. We plot them. So we can see our temperature is developing a little bit differently. And if we compare it to our contour plot, it was a bit less clear how it was looking. But this is our temperature down the stream. So we close it. And if we want to calculate our heat transfer rate at the wall, we can compute it. We can see that we have a negative heat transfer rate. It's reported here on the console as well. We can also look for our surface integrals, area weighted, variable. We want wall fluxes, and we want our total surface heat flux. No, we want our it at the wall. Surface heat transfer coefficient. There you go. Wall fluxes. We have to select the wall, we compute it, and we can see our heat transfer coefficient. So now we virtually solve for every single part of the problem for problem 3. So in the next tutorials, we're gonna start looking at this problem as a 3D problem.